got steps for predicting the behavior of a polynomial in our non-factored form. Still, the first thing we're probably going to need to do is locate or determine what that leading term is. Oops, that's really thick. There we go. That leading term. Because remember, that leading term lets us know two things, right? It lets us know the degree of the polynomial, and it also lets us know which way our arrows are going to point, right? If it's a positive or a negative. So from that leading term, since we can find those two things, we will be able to determine the end behavior. But we also are now going to be having to determine the zeros because it won't be in that factored form given to us. We're going to have to find the zeros. Well, in order to find the zeros, we have to find the factors. So we are going to have to turn it into that factored form or break it down into the factored form. And remember, once you have it in the factored form, if you end up with multiple of the same factors, that multiplicity, remember, is what determines what it looks like at that zero. Does it cross? Is it a bounce? Does it have a wiggle? So something like our cubic functions, right? Okay, so this is what's going to be determining that, the multiplicity of our factors. Okay, so let's look at example 1 together here. It says y is equal to x squared minus x minus 12. So what would be the leading term here? The what? The x squared, right. Remember, your leading term is the term that has the highest exponent in it, right? Okay, and now we can see that the degree of this polynomial is 2, right? So 2 tells us, because it's even, that the ends are going to point the same way. And the understood lead coefficient here is 1, right? Which is a positive number. So for our end behavior, what can we expect here? Both up. Okay, so now I just need to know where to plot the zeros, and then I can draw a sketch. Okay, well, the way it's currently written, I wouldn't know where the zeros are. But like they said here, in order to determine the zeros, you may have to break your polynomial into factored form. So in other words, we're going to have to break this down by factoring. So remember, the first part of our factors comes from the first term in the equation. What multiplies to give us x squared? Right? And then when we're trying to decide what to put in the end of the parentheses, we look at our last term, which is negative 12. And since there's no lead coefficient, we know it also has to add to give us this middle term, right? And understood negative 1. So what are going to be the numbers we put in our factors here? 4 and 3. Which one's positive and negative? Right. Negative 4 and positive 3, right? Because negative 4 plus 3 does give us this negative 1 here in the middle. Perfect. Okay. So if those are our factors, then where am I going to have zeros at? Perfect. All right. So I'm going to come over here, and I'm going to plot a 0 at 4 and a 0 at negative 3. And we said this one had end behavior of both ends pointing up, right? Okay, and then both of these factors have an understood exponent of 1 on the outside, right? So we know that it will simply cross through those zeros. So it's going to look something like this. All right? Okay, you guys try examples 2, 3, and 4, and then we'll share them as a class to see what we got. So remember, when we factor, we're looking for anything that factors, anything you can take out in any way. Mm-hmm.
Wait, what are you getting off?
Wiggles. Right here.
Forgot.
Cross when the exponent was.
1,
Bounce when the exponent was.
2. Oh, even.
Okay. Yeah, even. And then it'll be a wiggle if it's anything bigger than 1 and odd.
Odd. Okay. Okay, got it.
So you'd have to basically end up with several of the same factors, right? Like you'd have to be able to factor something, and maybe its factors are x plus 2 and x plus 2. Then that's really x plus 2 squared, right?
Yeah.
And then that would be a bounce. So unless you have the same factor, you don't have a bounce or a wiggle.
Okay.
Are we supposed to do 3 and 4?
Yeah.
Oh.
It's 5x, and it's 5x minus 3x plus 1.
No, because you have to have a positive 2. So you do 3 minus 2. No, 3 minus
Yeah, you can factor by grouping.
Yeah, put that over, that's 5. And then minus 3.
Next quiz. should be x squared.
Negative.
Yeah. I got negative 5, negative 3. You group these, and then you can group that in x plus 5 squared, and then x squared and 9 you can group together, and then you can factor that.
Wait, doesn't the 0 bounce?
Yeah.
Should I go with?
No, that was right.
I was right? Okay.
Yeah, it's like a negative 1.
Okay, I told you.
And then you can get over
Under.
No, I grouped the x squared and then negative 9 together.
Did you look up the factors? I thought you were looking. Did you look up the factors on your phone?
No, we were checking, and I was right. It says that it's negative 5 and 0, but then we got negative 5,
So you
negative
got
3.
0 and 5, negative 5 and 3.
Yeah, because this
No,
factors
x
into
squared
this.
minus 9, so you can factor that into x
The
plus
plus 3 and minus 3, is that what you're asking about? Yeah, because this factored into this. So you have when you solve this, you get a positive 3. When you solve that, you get a negative 3.
Oh, okay, what was this about?
Yeah, I get a negative 5.
You have to do,
On one?
Wait, on x squared, do you just like make it x squared?
I was using the x squared equals 0.
Which is just 0. Okay. 0, 0, each other. Negative 1, 0. 3, 6, 0.
Okay, so it looks like everybody was good with examples 2 and 3. Factoring by grouping has stumped a couple of us. So let's go ahead and go through them. Example number 2, what was our leading term there? Very good. Okay, and because we had an odd exponent and a negative lead coefficient, what was our end behavior? What do we expect for our end behavior on example 2? Good. Okay. Okay, then we want to try and graph it, but in order to do that, we need to know where the zeros are. So what did we do to factor number 2? Very good. So we factored out a negative 3x from both terms. When I factor out a negative 3x, we're left with minus 4, right? If we divide by negative 3. But yes, x squared minus 4. Okay. All right, so now I've got negative 3x times x squared minus 4. Are we able to factor this any further? Yeah, we got a difference of squares here, right? So we have negative 3x, and then our difference of squares factors are going to be x plus 2 and x minus 2, right? Okay, so where are we going to have zeros? Very good. Okay. All right, so 0, 2, and negative 2. Okay, and none of these factors repeated themselves, right? So they're all understood to have that exponent of 1. So we're not going to have a bounce or a wiggle, right? These are just going to cross right through our graph. Okay, so we cross through here, we cross through here, and we cross through one more time. Okay, example 3. What was our leading term for example 3? Good? All right, so even exponent and a positive coefficient. What's our end behavior going to be? Up, up. Good. All right. Okay. What did you guys do when you went to factor number 3? What did we do? Take out x squared. Good. Okay. So our greatest common factor this time is x squared. So that leaves us with 5x squared plus 2x minus 3, right? Okay. And then that was something we probably were a little more comfortable with factoring. All right, so first term, 5x squared. What multiplies to give us 5x squared? Good. And what multiplies to give us the 3? 3 and 1. Okay, and how do I decide where to put which one? All right. Because if we check inside, outside, that'll give us 3 and 5. What are my signs? Nice. All right. So what are my zeros, or where are my zeros? Uh-huh. -1, uh-huh. And 3/5. Good. Okay. So at 0, at -1, and then 3/5 would be a little over halfway, right? Okay. And you guys said both ends were up. These are understood to be, did we have a, oh yeah, this one has an exponent of 2, right? So we're going to have a bounce right there, right? Okay. All right, last one. Okay, so most of you guys got the factor by grouping, but I know it did give some of us some trouble. Remember when we factor by grouping, we literally are just making 2 groups, right? So what was our lead term on this one? X cubed. So what did you guys expect for end behavior? Good. Okay, so in group 1, remember I'm going to completely ignore group 2 for right now. In group 1, what's our greatest common factor? X squared. So I take out an x squared, and I'll be left with x plus 5, right? Okay. Now remember, the goal is to end up having some matching factors, right? So when I'm trying to decide what to take out of here, I want to make sure it's going to leave me with an x plus 5. So what can we take out of negative 9x minus 45? Negative 9. And it will, in fact, leave us with that x plus 5. All right. So since they have that in common, you can take it out of both pieces, right? And then I still will have that x squared minus 9 left over from both pieces. And then this is a difference of squares, right? So we factor it one step further. We've got x plus 5, but we also are going to have x plus 3 and x minus 3. So we've got 3 zeros at -5, 3, and -3, right? Okay. 2, 3, 4, 5. So -5, -3, and +3. All right. And all of these have an understood exponent of 1, so they will all be crossing. So the only one that we came across that wasn't crossing was this x squared term here gave us a bounce, right? Okay.